All right, Daniel, it's all yours.
All right. Yeah. Okay. Thank you for coming. Today I'll be going through the EDBO Plus and how to use it. So EDBO Plus stands for Experimental Design via Bayesian Optimization Plus, which is an interactive platform to guide chemists to optimize multiple objectives in a reaction. And so this is a interactive process where the experimenter inputs the results of reactions into the optimizer, and in return, the optimizer spits back suggested experiments, and this loop continues until satisfaction. Whether that means satisfactory results, so we have a good enough yield, we don't have to go anymore, or we just can't do it anymore, or we just can't proceed anymore because of we already exhausted the search space, or we just ran out of experiments, or convergence. And so the general workflow is as follows. First, you define a search space. So for example, you can define categories like solvents, so THF, DMSO, temperature, concentration. And so you can have both discrete and continuous variables here. After that, you will initialize the EDBO plus. So at this stage, you will be selecting the objectives. So do you want to maximize yield, minimize cost, etc.? And the number of experiments per round. So how many experiments do you want the optimizer to spit back at you to suggest to run the experiment? You can also define custom features at this stage. With these suggested initial conditions, the experimenter will go into the lab, run the experiment, and with the results, so let's say we're optimizing yield and selectivity, you'll input the yield and selectivity that you get from the instruments into the optimizer, and the optimizer will crunch these numbers and spit back suggested conditions. And again, this loop continues until satisfaction. And so in practicality, you can run this in two different ways. The first is our website, and the website's written here, as well as our Python/command line interface. And you can get the code from our open repository in our GitHub. And so first, I'll be going through both of these today. First, I'll be going through how to use the web. Okay, so you guys should see, yeah. So if you go to the website, and after you log in with your Microsoft account, you should be able to see this screen. And the first thing you want to do is click build. To click build, you can, just create a scope name. I'll just call it CCAS for now. Here you will be defining your categories. So let's say solvent, DHF, and DMSO. And these will be separated by commas. So just make sure that your category names themselves don't have commas inside them. I'll just create a few more. So temperature, 0, 20, 40. And then concentration, say 0.1, 0.2. And then let's do 1. Now you're going to create scope. And now you can see that it created this tabulation of all the combination of different features. So what we're going to do next is go to optimize on this left-hand side. Select the scope that you just created. You can select multiple from a list of multiple if you have multiple. Set up optimizer, and here you'll be guided to this screen. First, you'll be selecting which features you want to use. In this case, I want to select all of them, but you can select a subset of them if you wish. Add objectives. So here, let's say we want to maximize yield, and you can also define a threshold. So for example, if I set the threshold at 80%, the optimizer will not try to go further than 80% and focus on the other objectives. You can also select whether we want to minimize or maximize. In the case, we probably want to maximize yield. Let's choose another one, selectivity. And then, and the next one is the number of batch sizes. So how many number of experiments do you want to run per round? And so on the website, the maximum is 5, minimum is 1. If you want to go higher than 5, you would have to use our Python interface. So here, I'll just do that too. Run optimizer, and it will give you the initialized conditions based on our CVT optimizer initializer. So here you can download the scope. And here, I believe I have downloaded it in this folder. And so you can see that this is our entire scope. And again, just to reiterate, the goal is to find the best combination of conditions that give us the best yield and selectivity. And so here it is sorted by priority. And so those with priority, let me make this a little bigger. Those with priority equals 1 are the experiments you want to run. And so in practice, you would go ahead and run the reactions with these conditions, get the results. Right now, I'll just make up just arbitrary results. Let's say, I don't know, 90, and then let's say 23. So you want to save this in a CSV format. So this is after we run the experiments. Then we want to go to upload. And let's call this CCAS and then round 1. Yeah. Upload this. Upload. Okay, so now it says successfully uploaded scope CCAS 1. So now if we go back to optimize, now we should see CCAS 1. And then you're really going to just reiterate this process until a satisfaction. And you can also change the scope after you start the optimization campaign. So let's say, oh, we realize that solvent doesn't have an effect. Then you can unselect solvent and just go with temperature and concentration. And then you can also change the objectives midway. So in this case, I'll just keep it the same. And then, yeah, you can also change any of these in the middle of the campaign. And then you will select run optimizer. And now here, now these are numbers based on the numbers that we inputted in the previous round. And yeah, you basically repeat this loop until you, yeah, basically satisfaction. One thing I do want to point out is that you can download the predictions after you have input any information. And so the predictions look like this, where basically you have the same exact information as before, but you also have predicted yield and predicted selectivity, as well as the variance and the expected improvement. Yeah, and then yeah, if you download Excel or whatever, you can plot this however you like. Okay, so this is how you would go about using the web app. Hopefully that was clear. And yeah, and then so next I will move on to our Python interface. Oh, yeah, you should be seeing my, yeah, code. Okay, there you go. So again, you can get this code from our GitHub. I was just in the slide, which I could share as well. So this as a tutorial, this tutorial itself is also in the GitHub under examples tutorials, but I will go through this with you. So first, you want to create the search space, and here you want to put this in a dictionary format. So solvent, now we have these 3 solvents, temperature, and so on and so forth. If you have, and you can run this generate reaction scope method, which is run, you get the same tabulated data as before, where you get the combination of all the features. This you can do it by hand as well. You don't have to use this, but it just kind of streamlines the whole process. I want to mention that this file name that you input is saved as a CSV file. So if you want to read it, you can always read it. And so if you just right here, you can see that it's the same thing. It is now saved locally on your computer. All right. After you create this search space, you want to initialize the EDBO plus. And so we have this run method where we give the search space that we just created. So this should be the same as the one before. The objectives, so in this case, yield, EE, and then side product. and the corresponding direction. So we want to maximize yield, maximize the E, and minimize side product formation. You want to define the number of experiments per round or the batch, as well as column features. If you do not want to use all, similarly to the previous, this will be in a list format. So let's say we don't want to use solvent, all you have to do is write down the list of features that you want. So in this case, concentration temperatures, something like that. In this case, we'll use all. Initialization sampling method. By default, we have it as a CBT sampling, but you can change this to random as well. Okay, so yeah, let me run this real quick. Yeah, this is the same tabulation data as we did before, where we have the combination of features plus the columns for yield, EE, side product objectives, as well as the suggested experiments. So here we have 3 priorities because our batch size is 3. Okay, so let's say we go into the lab, we run the experiments, and we get the results back. Then you would do the same thing as you did on the website, where you would input the data. And so just to recheck, yeah, here are 3 experiments. And you can do this by accessing the pandas data frame itself, which is what they did in the tutorial. But you can also just go into the CSV file yourself and update it like I just did. And then so yeah, so if we do this, it updates the first one, and I'll also just update the second 2. And so now all the experiments that they suggest, I have updated with the hypothetical numbers. And so now let's save this. And now this is saved in my optimization round 0. And so we're basically going to repeat the process where we have the data and we want to rerun this run method, and so that we can get suggested experiments. Now you'll see this print statements because now it's actually doing some Bayesian optimization. So here you can see that all the input numbers are on the bottom and the priority is on top, and these are the experiments you want to run. And yeah, you just want to repeat this process until satisfaction. For the predictions, what you want to do is the code will save the predictions with the pred underscore prefix. So if your if our file name was my optimization round 0, it's just going to be pred underscore and that. And so if we run this, we can see that the the priority ones are similarly on top, and we get this extra information on the right. One thing I do want to add is that if you want to add custom features, so for example, we have this solvent, and let's say you want to customize this, and you don't want to have discrete variables, but you want, let's say you want dielectric constant, so you want a continuous features to represent the solvents. All you have to do is add a second column here called dielectric constant, and when you define the features, you're just going to include dielectric constant. Yeah. And so yeah, that's pretty much it. Hopefully that was clear. Yeah, and I'll be happy to take any questions about either methods. Thank you.
Thank you, Daniel. Questions from the audience? Maybe to start out with, in your experience, how many rounds of optimization do you typically need in a practical application?
I think that highly depends on the search space and whether you have training data or not. The work that I'm currently working on, we were able to converge within 5 rounds, but we also had training data from previous like optimization campaigns. I think Abby might know more on situations where we don't have any.
I mean, in the cases that we've looked at, usually it's in the 1 to 5% of the total search space is sort of the number of experiments, where you start to see convergence. But yeah, like Daniel said, it does depend. And certainly, clearly, you can define a very large search space where that 1 to 5% becomes impractical even.
Yes. Yeah, I'm thinking more of a novice user on trying to get a feeling for, okay, what am I getting myself into? Or as you said, what is impractical, if I'm trying to optimize everything from ligands to solvents to temperatures to generate a huge search space, you still pay a price for that.
For sure. I mean, we tend to keep things under 500,000 or less in terms of the search space when we've been using it.
I'm going to interrupt here too for a second. The stuff we've done with Daniel and Abby is, impressively fast on one of the more challenging aspects. And the search space wasn't massive, but we had limited it based on a first round or two of kind of a traditional optimization. But it took 4 rounds to double the yield and improve the selectivity by almost a kcal per mole. So pretty quick. And that was only, 20, 30 experiments, right, Daniel?
Yeah, it's 5 rounds. 5 rounds times 5 experiments per batch. So
yeah, so I can tell you from doing reaction optimization for a very long time in my life, 25 experiments isn't very many.
It's good to hear. Rob, you had the handoff.
I did. Can you hear me?
Yep.
Awesome. Yeah, so I was just going to ask a general question about how you deal with multiple objectives, and have you found there's a sort of best way to combine yield and EE or other types of selectivity? Do you have like a Pareto frontier, or do you sort of combine them into a single score? What's your thinking on that currently?
Yeah, that's a good question. There are multiple ways to go about this, and I think it really depends on your ultimate goal. You can always input the yield and selectivity separately. The problem with that is if you place more importance on, let's say, EE over yield, it's gonna treat like 90-10 and 10-90 the same way, and sometimes you don't want that. And so a couple of ways you can go about this is, number one, you can have a custom like weighting function where you place more weight on certain objectives. Another one is you can just input one objective and just have like isomer yields. But again, that runs into the same problem. So I think in that it really depends on the situation. And in my experience, we kind of came down to trial and error.
Thanks.
More questions? Ampofo.
Yes, just a general question here is for someone who uses the application here, what are some of the best practices in describing how you used it in the literature? Say you were to publish a paper on using EDBO plus. Do you have to go into, I guess, how detailed do you have to go into the technical aspects of how you use it, or is it as simple as saying, here's what I used, you cite the Jack's paper, and then you continue?
I see. So like in terms of, so just to reiterate, to see that I'm understanding your question correctly, are you asking on how to like mention how you guys use the EDBO plus in the paper?
Yes.
I see.
I mean, I think, sorry to jump in, but I think you can cite, the Jack's paper and maybe list the web app, and then probably in the supporting information, you'd want to maybe have the CSV files for the different rounds of experimentation that were prioritized. It's a good question, Ampofo. We haven't quite run into this yet, although we did have one collaboration with someone in the Department of Defense who used it. And we cited our paper. The referees definitely did ask questions, that got into the details of, EDBO plus, such that having some knowledge of it was helpful in responding to referee comments. But I guess that it's something we haven't yet fully had many experiences with.
And you will probably, if you're going to use descriptors also from molecules and stuff like that, you'll have to include that as
Those. Yeah,
you'll have to give those, and how you define your search space. I think I imagine it would be, Abby, a good idea to maybe think on what are the best practices.
Yeah, no, and having a document, a Google Doc, where we sort of list the information that you'd want to, provide. Yeah, it's a good question.
I see a question in the chat. Does specifying thresholds for yield impact the performance of the optimization? Yeah, so obviously if you set a threshold lower than what is the Oracle defined global maximum, it's not going to go to that point. And so the final result that you get will be lower. The point of setting a threshold is that sometimes you just don't care. Once it reaches a certain threshold, the optimizer itself doesn't change its algorithm or anything based on the threshold.
Yeah, I think that's right. Although I guess I would add, we've not done some controls on this, but because you won't be running, so the priorities are the experiments, right, that the algorithm suggests that you run, but it's going to change priorities based off of this threshold that you put.
Right.
And so the data that you put back into the algorithm may not be the best for actually improving the model performance if you've added a threshold, because it's looking for this Pareto front, as Rob mentioned, that sort of maximizes either of your two objectives. And if it's not seeing part of the search space, the actual algorithm, the predictions might not be quite as good as if you were running it without a threshold.
I have one more question regarding more of the technical details of the GitHub part, because particularly in industry, people might be somewhat reluctant using the website. So other than the code, the Python that you have on GitHub, are there any other things that need to be linked to run the optimizer, or any particular environments that they need to set up in order to do this?
Yeah, that's a good question. So if you go to our GitHub, we actually have any prerequisites. So we recommend using a content environment, and we actually have all the required specific libraries in a setup file, and this should satisfy everything with all the dependencies.
Excellent, because then people can run it in-house, which particularly in industry, a lot of people will prefer.
Right.
We also have the code for the web app, which is not open source right now, but we have helped some companies install the web app internally on their servers. It's a bit more involved, but if people sort of have reached out to us, we have helped them with that.
Yeah, because some people already have the internal workflows, so they might be interested in also tying it in there. Obviously, you want to make things as easy as possible for the synthetic chemists.
I mean, Abby knows this already, but I think most companies have their version of this already in operation. Most of the big companies we've talked to, and some are using Abby's code, and some are using modified code already. Is that right, Abby? That's been my experience.
Yeah, no, I think that's right.
They love it, by the way. It's quite amazing how fast it's been the uptake of this workflow is just super quick.
Yeah.
From Abby's first pub to the second, it's like it's popping up everywhere when I'm consulting and such. So it's pretty.
Yeah,
awesome.
for those of you who were at the NOS, the presentation from Jason on when they got the OPRD award was basically love letter to EDBO Plus. I mean, from the 45-minute presentation, I think a good 15 minutes were this. Are there any other questions? Then let me stop the recording.